Hi there and welcome to 272analytics.com's tutorial on how to run a Poisson regression in Stata. It's a basic tutorial today. We're just going to be doing it with two variables, your dependent variable and one independent variable. We won't be using operators or conditional terms or anything more advanced in this tutorial. I do recommend you check out 272analytics.com for the advanced version, where we do use a lot of that stuff. Next, before we get going, I want you to search for and install this command from UCLA. It comes with some really excellent code that I am going to be using today, and I highly recommend that anyone who works with Poisson regression has this installed. So if you search for this, push enter and follow the prompts, you'll be able to install that in your instance of Stata. Now, let me show you what I have here. These are the mocked up results of an experiment of 50 people, 25 males and 25 females, who are given exactly 4 hours each to go to a specific nightclub of their choice and collect as many telephone numbers as they can. And what we're interested in is using Poisson regression to figure out, is there an effect of gender on the number of numbers that was collected. And we're going to use this code to start off with. It's Poisson for Poisson regression followed by your dependent variable. Then gen is how I coded gender, and I put the I dot here for a reason that I'm going to explain in a minute. Then comma and IRR for incidence rate ratio. Before we see this code again, I just want to show you what it looks like when we don't have it. It's not very useful. Suddenly you have a coefficient, you have to insert these terms into a formula to get it interpreted, and you don't necessarily know how gender is coded here in that data set either. So it's a bunch of work to go in there and do that. And that's why I've used this code. Firstly, because we managed to break out gender into female here. And we came up with the IRR, which we're going to talk about in a minute. I think the most intuitive way to actually look at the IRR and understand it is just as the quotient here of the mean numbers obtained by women to the mean number of numbers obtained by men. So let me show you in the calculator, what that looks like. Women obtained 3.16 telephone numbers and men obtained 1.48, and that's 2.13. And that actually is our incidence rate ratio. And what the Poisson model is telling us is that it is statistically significant. So that's a quick way of quantifying how much better women were than men at collecting telephone numbers. We did this through Poisson regression for a couple of reasons. The first is that success is count data. Anything you can count is count data. So number of heart attacks, number of touchdowns in a football game, number of cars that run a red light, all those are count data. So we don't have fractions or anything going on over here. That's number one. Number two is Poisson regression is classically used when the time is delimited. So in this case, we had an experiment, right, where everyone had exactly 4 hours to do it. It's not that one person had like the whole night and another person had 1 hour. So it's a controlled block of time. And you'll notice that in Poisson regression, that is the standard assumption. So you're measuring something that happens every hour, something that happens every year. You're using comparable blocks of time, in fact, identical blocks of time to compare something. In this case, we're comparing the performance of women versus the performance of men in gathering telephone numbers. Nonetheless, you could say, why not apply a t-test or something here? That's what I did, and you can see that the t-test is significant here. We found out through this other means that women are likely to collect about 2.3 more telephone numbers than men over the course of a night. So why use a Poisson regression at all? Well, the first thing is Poisson regression has this wonderful relationship to odds that's very intuitive, it's very powerful, and just so simple to use when you get it. Before I show you exactly what's going on here, let me highlight this code here for you. Pprob, comma, mean, and 2.32 in the parentheses, and n for 7. 2.32 is lambda, and lambda for Poisson regression is the mean. It's the mean number of successes, events, whatever. And we noticed that, in fact, that is the mean number of numbers that was collected that night, was 2.32. So using this code here from UCLA, we put that into the mean, and then we put 7 under n. And what is 7? Also known as k. That's just the number of telephone numbers. This is arbitrary. We could change that for example, to, let me show you what it looks like when we go down to like 4. Um, the odds don't change, but what this code does, is it lets us compare the odds of people in this experiment, which is just a very powerful thing to do. Let's say that someone comes to you and says, "Hey, I got no telephone numbers that night. I must be the least lucky person in the world," right? You know what you could tell that person? You could say, "Well, it turns out there's almost a 10% chance of someone collecting no telephone numbers that night. Turns out you weren't really that lucky, or unlucky in this case. Uh, but look over here for 7 numbers. Look how hard it is to get 7 numbers. It's less than a percent. Uh, 0.7% chance of collecting 7 numbers on that night, and a 2% chance of collecting 6 numbers on that night. So what this does is it shows you the odds that are associated with specific successes. And I think that's just a very, very powerful thing, because look over here in this cumulative box over here. That also tells you really cool information. Like, for example, you know that 99% of people on that night did worse than collecting 6 numbers. Actually, I phrased that in a descriptive way. We should just think of that as a probability instead. We should think that, okay, there was a 99% chance that you were going to get someone was going to get less than 6 numbers on that night. So this really lets us look at this whole range of outcomes through the lens of distribution and odds, which is something that this t-test is never going to give you. Using this t-test, okay, all right, you figured out that women did better than men. So what? It's one of those scientific findings where they figure out that water is wet, right? What's the use of that? Well, when you use this Poisson regression approach and you build your probability table, now you start to get really precise. You start to get insights that constitute real analysis, as opposed to your t-test, which really isn't as informative. I'm going to show you what the graph bar looks like of this Poisson distribution and talk about it a little bit because it's relevant. Down here we have the number of telephone numbers, right? And I've gone all the way up to 12 just to show you. We could have stopped here at 5 or 6, but I showed you the whole 12. And here on the y-axis we have probability. So here is probability 0, and up here is 0.3, 30%, if you want to think of it that way. And what we see is that there's a big spike here at 2 and 3. So that night, the best chances here were for collecting 2 or 3 telephone numbers. There's also, pretty fair chance that you collected one, or fewer numbers on the night. And then what you see is that after about 5 here, it really starts to drop off a cliff. And that's the same thing that I talked you through earlier. What I did with this graph is I just took the numbers that were generated through this code over here, probability and k, and I just typed them in here to Stata so I could generate that distribution and show you what happens to the odds. Poisson regression was historically used for low frequency events, and one of the first instances it was used on was when there was a model of the number of people kicked to death by horses in the Prussian army sometime in the 19th century. As you can imagine, that's a very unlikely thing to have happen. And statisticians wanted to think about the odds of something like that. That's a very interesting question. It doesn't happen really frequently enough, right, for it to be analyzed in other classical ways statistically. So the Poisson regression came in there as a way to model this. And it would be really good for these kinds of low frequency things. The number of, I don't know, lotteries that might be won in a particular state, that kind of thing. Poisson regression has been modified and now is used for, higher frequency events as well, but its classic use is for things like what I just showed you. And one of the keys there is the shape of the odds distribution. And that's why we use the Poisson regression, in my opinion, because in this example that I showed you, we can easily use a t-test to reach the same basic conclusion, but that's not going to help us understand the odds that happen at each level, at each number of telephone numbers that was collected. Anyway, I hope this tutorial was useful for you. It's a subject I'm passionate about. Poisson regression is one of those techniques that might not get used very broadly outside of technical circles, but it is immensely useful anytime you have count variables. And the thing is, I don't know how many theses I've seen where people actually do have count variables, and Poisson regression is perfectly legitimate to use, but because of a lack of familiarity, other techniques get used instead. And a lot of analytical rigor, I think it's just left on the table there. I do recommend you check in on 272analytics.com. We have a ton of free tutorials in Stata, SPSS, R, Minitab, and eViews. We have made all of them available for free simply for the reason that we are data consultants. We want to give you as much information and assistance as we can, and we also want to show you that we are data experts. So please work with us for your Chapter 3 needs. If you're a graduate student, Chapter 4, we'll help you craft your methodology, analyze your data, code your data, interpret them. We'll essentially create a blueprint for you that will help you write your perfect Chapter 3, your perfect Chapter 4, do your dissertation defense, and do very well in any academic assignment that you have that has a quantitative analysis component. Thanks for listening and have a great day.